we have long division. We've seen that through prime factorization we can still calculate the square root of numbers, but there comes a case when we now have large numbers, like when the equation is find the square root of this. We find that prime factorization becomes long and difficult. So there's another way in which we can try to save time and space through this long division to calculate the square root of this. But then we must first identify what we are expecting. When you are given a number like this, in your brain before calculation, you should be able to determine the number of digits going to be in its square root. Now, how do we determine those numbers? Determining the number of digits in a square root. If we have this one, 4096, then we have 529. We know both of them are perfect square numbers and they have square roots. But we can be able to determine the number of digits in each square root before we start calculating it. This is how we do it. When we have a perfect square number with even numbers, then the number of digits in each square root will be n over 2. But when the numbers of digits in the perfect square number is odd, then the number of digits in each square root will be n plus 1 divided by 2. Maybe someone is not with me up to that point. This is what I'm saying. When you are given a number like 4096 to find its square root, we can determine the number of digits in the square root before we calculate. We will count 4096 as how many digits in it. We have 1, 2, 3, 4. We can see that the total number of digits is 4. And 4, from your knowledge, 4 is an even number. So we will take 4 and divide by 2. The answer is 2. It means the square root of 4096 will have 2 digits, like A, B. These ones are 2 digits. That's the way the square root will be. When we have a number like 529, we can see that these ones are 3. We have 1, 2, 3. We have 3. This 3 is an odd number. When we divide by 2 directly, we are going to find a decimal fraction. So what we do, we add 1 to the number n, then we divide by 2. This one makes it even so that we are capable of dividing by 2, so that we have 2 as the number of digits in the square root. Now, let's do this to see if that one is actually what is going to take place in it. The steps we are going to use are long, but we will have to go through it. The first one, we will pair the digits in that perfect square number starting from the one column, moving leftward. Like in this case, we have 4096. And I've said pairing means grouping into 2. So for us to pair them, we will show pairing by a bar on top. This one. So this one becomes our first pair, and this one is our second pair. When pairing, we start from the one column, as we saw in the place value yesterday. We start from the ones column, moving to the left. Now we've paired. After pairing, we will go forward to do division. And in that division, there are key things that you must know. Long division, this is the symbol. We always know that in long division, there's a number, let's say x. That x, we are dividing it by y to get the answer z. When you have 4 through long division, we will use 4, we divide by 2 to get 2. Now in my case, x represents 4, y represents 2, and z represents 2. This one, we call x the dividend. Y is known as the divisor. Then z is now the result after division. We call it quotient. You must be able to familiarize yourself with the three. Dividend, divisor, then quotient. Quotient is the result we are getting after division. The divisor is that factor we are using to divide, while the dividend is the number we are dividing. Now, this one, after pairing, we are going to move down to put it that way, where we have 4096 as the dividend. Now, we want to determine the divisor outside. What do we obey? We take a value that its square is less or equal to the first group, the first pair, the value in the first pair. We know that our first pair is 40, then 96. Now the divisor outside must be a number whose square is less than 40 or equal to 40. Whose square? Make sure that you square first that number. And the answer you are getting after squaring must be either less than the value in the first pair, or it is equal to that. In this one, we can check. When we square 4, we are getting 16. That is too low. When we square 5, we are getting 25. That is still behind. When we square 6, this one is now 36. 36 is very close to 40, so we can take 6. The square of 36, the square of 6 is giving us 36. Then we subtract, we are getting the difference, that is 4. We know that this one, the divisor here, is the quotient, because when you take 36 and divide by that, you are going to get 6. Always in this method, the divisor becomes the first quotient, the first value of the quotient you are writing above. Always remember that. Now here, after getting the difference, we will go ahead to drop the values on the second pair to the right of the difference. This is the difference after subtraction. Now we are taking the values of the second pair, we are dropping them to the right of the difference we are getting. That will be 96. So down there we are having 496. How do we move after that? What we do is that we double the divisor. This divisor up here, we double. To double means to multiply by 2 and get the difference. To square is multiplying a number by itself. Let's say a by a. But double, we will multiply a number by 2. That's a times 2. This one is doubling while this one is squaring. Now, when we double this divisor here, we are going to get 12. But this 12 must be multiplied by another number for us to get the answer we are getting down there. So we will leave a blank here to get that number, so that when we multiply the number in this blank by this, we are supposed to get 496. In that step, we are going to guess. We are going to guess a value that when we write after this and multiply it by the same value we are guessing, we are supposed to get 496. Now let's try. When we have 122 by 3. The last one should be 6. That will be 6. This one will be 6. That is 3. This one is still less. Let's take 124 by 4. Remember, the number you are putting in this blank space must be the number you are going to use to multiply down here. It is the same number. When you put x here, it is that same x that you are going to use to multiply this, so that whatever you are getting down here as your result must be equal to the number down there. Now, when we use, in this case, this is wrong because we have used 2 and 3. If it is 2, I should multiply down here by 2. Like in this case, I'm using 4 to fill the blank space. Then that 4 is what I'm going to use to multiply this 124, so that I check if the answer equals to. The answer we are getting should be equal to or less than this. If we do this, we are going to get 6. We carry 1 because 4 times 4 is 16. Now 4 times 8, 4 times 2 is 8 plus 1, we are getting 9. Then 4 times 1 is 4. Now we can see that in this blank space, when we fill in 4 and multiply by 4, we add 12 after doubling 6 here. Then this blank space, when we fill in 4 and multiply by 4 again, we are getting 496. So if this one is going to give, if here we have 496 and this one is giving us 496, when we subtract, we are going to get 0. When we get 0, it means the value here is the second quotient, the second part of that quotient. Now we had seen that when we use n, when we use the formula n over 2 to determine the number of digits in the square root, we were having 4 over 2 to give us 2 digits in the square root. Now here, my answer is 64. I believe when you square 64, you are going to get this. And we can see that in my square root, I have 2 digits. Now this one proves to be the correct formula of determining before you calculate. And that is correct. Let's do another example. That will be example 2. We have this. We are supposed to determine the square root of 529 through long division method. We do it this way. We can first determine the number of digits in the square root by using n, because these are 1, 2, 3, so we will have n plus 1 over 2. That one is 3 plus 1 divided by 2 to give us 2, because this is 4 divided by 2 giving us 2. Now through long division, we'll have 529. The first step is to determine a value whose square is less or equal to the first bar, because when we pair, we are going to find 5 alone, then 29 on the other pair. This one is because the number of digits is odd. So the one on the extreme left will be a single number, single digit, but the other one will have a pair. That is when it is odd. And when it is even, both will have a pair. Now here, the first value whose square is less or equal to this is 2. We know the square of 2 is 4. 4 is less than 5, though very close, where as compared to when we use 1. 1 is 1, 1 squared is 1. 1 is very low. We can decide to use 4. So we will use 2 as our divisor because its square is 4 and that square now is there. We find the difference to be 1. The quotient is the divisor, 2. If you remember the quotient, the divisor and dividend, the quotient up there is the divisor we are using. Now up to this point, after getting the difference, we will drop the pair after to the right of the difference. So we have 129. Okay. What do? After reaching that point, we come back to this divisor and double it. It means we are multiplying by 2. Whatever we put in this blank space, we'll multiply the whole of it to give us this value, or a value that is just less than it. So here is multiplication. This one is a proof that that digit should be the one to be the next digit in the quotient. Now, it is upon us to guess a number that when we multiply by this, we will get that. Let's say in that blank we have 4 and a. We will multiply by a to see if the answer we are getting here equals to that. What I'm stressing on is that the value you put in the first blank space must be the value you are using to multiply the whole of it now. Here, we can guess, let's say 3, so that we have 43. In this blank, we are putting 3. And when you put 3 in that blank space, we also multiply by 3. Now we have 43 by 3. What is the answer here? 3 times 3 is 9. And 3 times 4 is 12. So that one is a correct guess. We have 129. It means in this blank space will be 3. Remember that this number here will be the next quotient. So the square root of 529, root 529 will be 23. Another technical example, that is example 3 now. Example 3, we are given this. Find the square root of 2304 using long division method. They are specific to long division method, and the number we are given is 2304. As you have stated the steps, the first one is to pair. We will have 2304. We pair from the one column, one place value column. We will start from this side. The pair, we have 04. Then we have 23 as the next pair. This one is to the extreme left. Now we've known the pairs. We come to the division now. We have 2304. Those are our pairs. We determine a value, because this is now the dividend. We determine a value that its square will be less or equal to the value in the first pair. This one is now our first pair. Now the value we are determining as the divisor, its square must be less or equal to 23. As we've seen squares, we know that 4 squared is less than 23. But 23 is less than 5 squared. Now we can't go for 5 because it is a value higher than 23. But we will take 4 squared because this is 16. Now here we will have 4. Our divisor outside becomes our first digit in the quotient. You can determine in that method the number of digits in the square root, but I'll not do that this time. Now when we have 4, we will find 4 squared, that is 16. Its square, the square of this, must be less or equal to the value in the first pair. Now our value here is 23, and the square which is less than that is 16. We get the difference there. 23 minus 16 is 7. When we do this, we now drop the second pair to the right of the difference. We have 0, 4. Up to that point, we will now go ahead to double the divisor and drop it down. Now when we double 4, we are getting 8. This 8, we write it with a blank space because there's a number that when we fill in here and then multiply that number by this, we are supposed to get a value which is less than 704 or a value which is exact 704. Now, the value we insert there should be the value we are using to multiply the whole of it. Now we have two blanks. This one should give us 704 or a value less than that, but it is upon us to guess that value. Now you go and guess. Let me guess this side. We have 80. Not 80 really, but 8 and a blank. Then another blank space, and I'm supposed to multiply. Okay, in our answer I should probably get 4. Let me try with 4, that is 6, 5, 6, 7. Let me try with 8. Then I multiply all of it by 8 because 8 by 8 will give us 64. So I'll write 4 and carry 6. I think I'll be close or exact. Now 8 times another 8 is 64. 64 plus 6 is bringing me to 70. So we can see that when we fill in 8 and multiply by 8, we are getting 704. Then our difference there is 0. When we have 0, then the values that we have is the square root. Then remember, the value you are filling in here is the second digit in that quotient. So the square root of 2304 is 88. You can find others to try. Let me give you find the square root of the following. We have 729. We have 961. Then maybe 1024. Last thing about this, I want to show you something that you can use to detect whether a number is a perfect square or not. When I have a table like this, let's say square. I have 100. That is a perfect square. Then I have 361. After that, I have 36. Then I will go to maybe 729. Can you check the number on the ones column? We call it unit place. You'll realize that most of them, or all perfect square numbers, will always end with this. we have 0, we have 1, then we have 6, 9. Always we have numbers like 5 can also be there. We have 25, we have 225. So 5 also is among these. When you find a number, just before you determine the number of values, the number of digits in square root, you can just check through this. You find any of this digit in the last or in the unit place of that number, then you'll realize that it is a square number. Let's have also 4. We've seen 1024, 64. We've seen 124, 144, sorry. So these ones, if in this group any of these numbers fall in that unit place, the last digit of that value, then you'll obviously know that that is a perfect square number. Thank you.